Hi everyone, this is Vinil. Today I'm excited to share my project which combines artificial intelligence and the finance to predict the Nvidia's core prices using the news sentiment. So this project develops a relationship between the market sentiment and the price movement. So which is like highlighting how the machine learning can uncover the meaningful insights over the next few minutes. So I will walk you through the data, methods, and the results and the future possibilities of this wonderful research. So speaking of the stock market operates on both like high quantitative and the qualitative factors. Numbers like earning and the revenue tells us one story, but there is a other story which tells us about the emotions and the precisions reflected in the news headlines often tell us the other story. So in this project, I explored how the sentiment extracted from the NVIDIA related to the news impacts the stock prices. So the reason why I chose Nvidia is because it is prominent company with significant market activity, ensuring an abundance of news and stock data for analysis. So thus news is like large, so it will help us better to understand what is our project is going on. So moving on to our data. So data is a key factor for this project. So I have like two different types of data. One is like the news data and one other is like a stock data. So starting with the news data. So initially I would scrap like 90 days of NVIDIA data. So to train a model. So next, I grew this data set like from changing from 90 days to 3 years. So taking some of the initial features like title, source, publication date, and the sentiment scores. So I done this sentiment scores using the Finbot model, a model that is like well tuned for financial statement analysis, financial sentiment analysis. So where is the stock data? So as we scrape the data of the news like from past 3 years, I took the exact dates and uh, started to scrape data from the stock market, which is I use like the Yahoo API. So which was so helpful and extracted the data with some key features like the stock opening market price and the closing market price, highs and lows on the particular day and volume. So I took it like initially for every 1 hour of data. So then I merged these two datas and where which is like qualitative sentiment with the quantitative price data. So there's the nature of my data set. So moving on to the project goals, the primary goal of the project is to predict the Nvidia stock prices by both sentiment and historical data. Beyond those predictions, I aim to evaluate how sentiment directly impacts the market and to compare these performances to different neural net models. So moving on to my models and methods. So I use like four different type of neural network architectures: LSTMs, improved LSTMs, CNN, LSTM hybrid, and GRUs. So speaking of the LSTMs, so the reason why I chose this, it is like an better it gives us like better accuracy and it captures like a long-term dependencies in the sequential data. So this is why I chose LSTMs. So moving on to the improved LSTMs. So this was taken because of this additional optimization. So which is better than the LSTMs and it gives a better accuracy. So I chose the second I chose is like improved LSTMs. The other model is like CNN LSTM hybrid. The reason for choosing this is like it was used to combine the short term and the long term pattern recognitions. So this might be much useful than the LSTMs. And finally, the GRU model. This is like a simpler and faster alternative when compared to when compared to the other models. So moving is my next slide is like the results. So this will be discussed by Kaushik. Thank you.
Okay, so hi everyone. My name is Narayana Kaushik, and I'm going to talk about the results that we achieved and our future work that's going to be done. So, when evaluating our models, we relied on two metrics, mean squared error and mean absolute error. These measures are standard in predictive modeling. MSC penalizes larger errors more heavily, and MAE gives us a straightforward average of prediction errors, making it easier to interpret. Our baseline LSTM model produced an MSE of 73.78 with an MAE of 7.86, which is good, but which can also be improved. By refining hyperparameters and adding regularization, the improved LSTM reduced errors significantly with an MSE of 0.00047 and MAE of 0.0162. However, the CNN LSTM hybrid architecture delivered even better results, combining local pattern detection and sequential trend modeling to achieve an MSE of 0.00029 and an MAE of 0.0127. Finally, the GRU model outperformed all the others, achieving an MSE of 0.00022 and an MAE of 0.0098. This performance highlights how, in some cases, even simple architectures can outperform more complex ones by avoiding overfitting and maintaining computational efficiency. These results are crucial for applications where speed and accuracy are both critical, such as financial forecasting. And moving on to the next slide. Sorry. Moving on to the next slide. Here, one of the most compelling ways to demonstrate model performance is through visualizations. This slide shows the predicted versus actual prices for NVIDIA stock. Here, the GRE model stands out for its ability to closely follow actual stock price trends. If you observe the chart, the predictions align well with the actual stock prices. This alignment demonstrates the GRU's robustness and adaptability to the dataset. In contrast, other models like LSTM or CNN LSTM hybrid showed more deviation, which reflects the importance of matching the model architecture to the data's characteristics. This graph also underscores why GPU performed better, its ability to focus on critical trends without getting bogged down by irrelevant or noisy data points, while CNN LSTM handled short and long-term patterns. Well, its complexity made it prone to slight overfitting in some instances, leading to less precise predictions. And this project is not without any challenges. Uh, One major hurdle was aligning timestamps between news and stock data because news articles and stock prices are recorded at different frequencies, news being event driven and stock being time driven. We had to synchronize these two datasets to ensure accurate feature engineering. Another significant challenge we handled was handling noisy data. Financial news headlines often had a vague or subjective language, making it difficult to derive accurate sentiment scores. For instance, a headline like Nvidia's outlook remains uncertain amid market volatility. It doesn't offer a clear positive or negative sentiment, which can confuse sentiment analysis models. Finally, there was the issue of balancing model complexity and computational efficiency also. While deeper and more intricate models like CNN and LSTM can theoretically capture more detailed patterns, they also require significant computational resource. This trade-off forces us to carefully consider which models were practical for our goals and for our dataset. So this challenge reinforced the need for a thoughtful approach to both data preprocessing and model selection. Coming to the conclusion and the future works that we're going to do, uh, our study, in conclusion, our study has demonstrated the potential of neural networks in predicting stock prices using a combination of sentiment and stock data. Among the models we tested, GRE emerged as the most effective, achieving a remarkable balance of accuracy and efficiency. This makes GRU well suited for tasks like real-time stock price prediction, where speed is crucial. And in terms of future work, if we talk about future work, there are several exciting directions to explore. One possibility is incorporating real-time prediction using live data streams, which would make the system more dynamic and responsive to current events. We could also expand the analysis to other sectors or industries to understand how sentiment impacts different markets. Additionally, by adding macroeconomic indicators such as interest rates or GDP trends could provide more context-aware forecasts. And lastly, experimenting with advanced transformer models like BERT or GPT for sentiment analysis could significantly enhance the quality of inputs used for prediction. So this research has not only provided practical insights into the stock market prediction, but also demonstrated how neural networks can bridge the gap between quantitative and qualitative data. By integrating market sentiment with historical trends, we've laid the groundwork for more sophisticated financial forecasting system. And thank you. That's it about our project. Thanks.